Hello, yeah, in this video, I want to continue to talk about how to fit linear mixed models using the R package lme4 with some additional analysis we can do. First, let me load in the lme4 package. And also, I need another two packages. One is called the lme4 test. For calculating p-values in mixed models. And the other one is called influence.me. This is for influence diagnostics in mixed models. Okay. Set a random seed. I'll create a data set. And this is what it looks like. A very simple data set with subject and time and then outcome variable. No covariates. Okay, just keep it simple. And then I'll fit a linear mixed model using the lme4 function. And I specify remo equal to false to make sure the estimation is maximum likelihood. So I can, after I did that, I'll just print out doing a summary of the model. And you can see in this summary, now the coefficient table for the fixed effects now has a column of p-values. Okay, if you still remember the first video on lme4, if we did not load this lme4 test package, then this column of p-value will not show up. Okay, so okay, and then I want to show you how to compute some other statistics related to mixed models and can be computed by using the lme4 package. First one is the AIC value. So you simply use the function AIC, and then you can print it out. And we know the AIC value is very useful for model selection. Not only it can be used for select different formulas or the functional forms of the independent variables. For example, linear term versus quadratic terms. Not only this formula, but also the correlation coefficient, okay, the correlation structure. So the AIC is very useful, and also it makes mixed models has very good model selection tools. But keep in mind you have to have maximum likelihood as the estimation method. Okay. All right. For linear mixed models, there are also other two very important estimates. One is called BLUP, which is the best linear unbiased prediction for random effects. Okay, so random effects in the linear mixed model are sort of like latent variables. They are hiding behind the scene, but there's a cause of the correlations among the repeated measures. And once we fit a linear mixed model, we can generate predictions for these random effects values. And what we need to do is really just call the function ran EF, so of model, and then we get the subject component. And these will give us the BLUP estimate for random effects, okay, per subject, okay. And then there's another type of estimate called the BLUE, best linear unbiased estimator for fixed effects. Okay, so you have the random effects, you have the fixed effects. Once you have a fitted linear mixed model, you can generate predictions for both. And to calculate the BLUE estimate, you simply use the fixed EF. model, and then you can print it out. This is the for the coefficient. So this is the fixed. And we talk about best linear unbiased prediction and best linear unbiased estimator. So these two estimates, BLUP and BLUE, they have some kind of optimal properties. So in this our video, I will not go into the theory behind the BLUP and the BLUE, but they are very important for linear mixed models. Let me just make a few remarks here. BLUP estimates random effects. BLUE estimates fixed effects. And you use BLUP for individual or group-specific adjustments and predictions, while BLUE represents the average population level effect. Okay. And BLUP is a kind of a shrinkage estimate in the sense that it adjusts random effects estimates by shrinking extreme value toward the population mean. Okay. So if you really want to understand all these, you have to dig into the theory behind the linear mixed models. Okay. Out here, I just want to put down this remark to help you get some sense about these two kinds of estimates. Okay, and we can do some additional analysis just using these estimates. But here I just want to show you how you can compute them. Okay. Okay, the next one is of course residuals for regression diagnostics. So you can calculate residuals by resid function. And then you can get the fitted value using the fitted function. Then you can simply plot out the fitted value against the residuals to see if there's any patterns. These residuals plot shows almost no clear patterns, and the majority of the data points are within like -3 and +3. So it's pretty good. And then we can, of course, draw the y equal to 0 line there. Okay. Also, you want to look at the residual distribution. Use the histogram, and it looks like pretty normal. And we know normal distribution is assumption of linear mixed model. So that is not a big concern. We can also generate a QQ norm and QQ line, and also not big concerns here. Okay, still very normal. We can compute confidence intervals for fixed effects using this function called the confint dot mod. This function comes with the lme4 package, so you can simply just use this function on model, and you can specify method equal to world. And there are several other options, I think, including like a profile confidence intervals. You can select what type of interval you want, and then you can print out the confidence intervals for the intercept and the time. Okay. All right. And then we can also calculate more diagnostic statistics, such as influence values, the leverage diagnostics, hat values, using the influence. So we get the observational level influence measures, and hat value, we use the Cook's dot distance, the Cook's D distance of influence diagnostics. And so we can print out the hat value, and this is not as useful as print out the hat value. And then we look at this, we calculate H equal to 4, which is the threshold line. And any observation that really goes beyond this threshold line, then it's potentially like influential data points. So this is how you use the Cook's D. Looks like in this data set there's some influential data points. Okay, and also we want the influential observations here using the a hat value greater than 4 over length of hat values. Okay, so and we can print out all these observations. These are the observations showing the vertical line shoot above the threshold line in the graph. Okay. And we can also generate influence diagnosis for random effects. We use the influence function and specify group of the subject. Okay, and then we can plot them out. This is another type of Cook's D distance for random effects. So you can take a look and identify if they're too far away from the majority, then they are suspects of influential observations. Okay. And we can do some model comparison and a diagnostic using the library performance. And we can do check models. Okay, yeah, it says we need to install something here. I'll type yes. Installing package. Okay. All right. And now you see this posterior predictive check model predicted lines should resemble observed data lines. Yeah, mostly it's a little bit off in the middle, but maybe not too worrisome. Yeah. And also you can calculate the model performance metrics, and these are the AICc and AICbic, R squared, R conditional versus R squared marginal, ICC, RMSE, and sigma. And these are all important metrics for the model fit. Okay, and we know the AICbic, the R squared, and the ICC measures the intercluster correlation, the redundancy of the observation. RMSE is I think, the metric for prediction errors. What sigma? I need to check on that. But you can find out using the documentation for this function. I leave that for you to find out. Thanks for watching.